Sort the inventors by birth date, oldest to youngest. So if you've never used sort, the way that sort works is that you get two items, and you have these two items in your hand, and you're asked to sort just those two items. So you say, is person A older than person B? And if so, you put the older person on top. And the way that we do that is by returning 1 and -1. And that's going to bubble these items up and down in the array. So we say const ordered equals inventors dot sort, and we have a function, which that function is going to give us like the first person and the second person, or a lot of people just like to use A and B. So whatever you prefer though. So the first person is going to be A, the second person is going to be B, and then we will say if A dot, and we need to do it based on their birth date here. So A dot year is greater than B dot year, then we return 1. Else, you return -1. And that's just going to move these people up and down in the, you can sort of imagine them bubbling up and down inside of the array that we have. Let's take a look at what you hear. Oh, we got an error here on line 39. What did we do? Should be able to spell function right. There we go. And now we have the oldest people here.
Okay, I got something I did wrong. So I got else. Oh. Return 1. What's wrong with my else? Return -1. Okay, so what did I do here? Be here, return 1. Else. Oh, wait a minute. There we go. Okay. Okay. So he does his differently than what we did in the functions that the book said the other day. Like he does this if and return, and we had two different functions, one ascending and the other one descending. So there's multiple ways of doing the same thing. It's really up to you how you want to do it on this one. Let's see if that was the end of this video. We'll actually save it, make sure mine worked. Oh, what did I do after argument list missing? What's after missing after argument? Oh. Now what? I got 7 errors. What errors do I have? So line 40. So this curly bracket is related to this one. This curly bracket, what's it related to? This one. Okay, those are related to each other. This one is that one is that one, and this one is an unknown maybe? Okay, got us down to 6 errors. Why is so ordered inventors.sort? So we have our arguments right there. What's expected on this one? Nope. Let's look at what he has. So const ordered equals inventors.sort. open parentheses, function AB. Okay, down to one error. And 63. I haven't done that one yet. That was one he put in there, so I'm not going to worry about that one. So this should work now. And it don't. That's why I put that. It says missing after argument list on line 49. Oh, 49. So let's see if I'll put a parentheses in there. That'll fix it. Oh, that fixed the other one too. So let's try this. Well, it's better. HTML36. Okay. What happened to my template? So how did that get messed up? Okay, that's fixed. Now I just need this. Oh, console log. Okay, so they're ordered by year. A year, B year, assuming. Okay, yeah, it's their birth year. Go ahead and get rid of that. So ordered, and they are in sequential order. Yes, okay. So I'm going to find that video I was wanting to show you on the other one. If you've already watched the video, you've already seen it. I'm gonna do that one because that's what I'm playing with. CS50 bubble sort. And let's see. He's got a more current one. Let's see. 2819. Let's do 2019. Try 2018. He's got another one. If I can't find it, we'll just do this one.
So I can just stop. And indeed, the bubbles.
So he's going to explain about bubble sorting on this.
Allison. All right. Come on up. So if you've ever sorted something before, now is your chance. So now, and you can put the numbers on the music database records, any number of problems in this world now require sorting sometimes, whether it's on Google or Facebook or your own computer. It feels like we need a good algorithm for actually doing that sorting. So how can we go about doing that, not just with blue books, not just with cards, but more generally? Well, let's try to frame the problem first with a simpler world. In fact, we can generalize blue books and playing cards is really just numbers. Or some piece of data that there's a defined order or sequence to them. And suppose I have these numbers here. How do I actually go about sorting this many numbers? Well, for this, and this will be our last chance for audience participation here, I need 8 brave volunteers. Actually, come on up. All right, so 1, 2. Okay, this is what everyone's been waiting for. 1, 2, 3, 4, 5, 6, 7, and 8. Thank you. Come on up, and I will meet you over here. All right, come on over here. If you want to grab 2 music stands. Okay, so let's go ahead and turn these around like this if you could. It's though the music's going to face the audience. Okay. All right, and let me go ahead and give you sheets of paper, and then we'll resume here. All right, so here is our 8 music stands, and what we have here is 8 pieces of paper. And each of you guys is going to take on the role of a certain number right now. So I'm going to go ahead and give each of you a number in sorted order initially, but that would be too easy. So if you don't mind, let's go ahead
and arrange yourselves behind these music stands in the same order that you see on the screen. So on the left end here near me should be the number 4, then 2, then 6, then 8, good job, then 1, then 3, then 7, then 5. All right, so now, and you can put the numbers on the music stand there, but just move them with you as you go. So now the question is, here is a seemingly random list, just some order I came up with somewhat arbitrarily, and I want now to sort my list. How do I go about doing it? What would you propose? The goal is to get from 1 to 8. What are our possible approaches here? Oh, you want to? Sure, okay. We'll just do it over here. Okay. Okay, good. So let's go ahead and do that. So let's see, and for those tuning in at home, what's your name again? Allison. And? Alex? Adam? Brandon? Joseph? Vicky? Arpin? Derek. Okay. So now, because that all just was too much to absorb, number 1 is now the first smallest element according to the proposed algorithm. So what are we going to do exactly with number 1? Okay, good. So pop back if you would. You guys are going to shift 3 places this way, and we're going to insert number 1 at the beginning of the list. All right, so what's the next step, just to be clear? Good. Good. So we find the next smallest element, which happens to be 2. We insert him at the beginning of the list here, and now we move on to the number 3 problem. Excellent. So pop back, shift, and insert. Good. 4, we got lucky, so we don't have to do any extra work here, so that's a freebie. Now we look for 5. Oh, there's 5 at the end. Good. And now 6, we got lucky. 7 and 8, we need to fix that. Okay, good. So I like this. It felt pretty fast, though to be fair, the list is pretty short. But we were doing kind of a lot of work, right? In fact, that was perfect, the fact that number 1 was all the way over here, because we shifted 3 humans. And can you guys reset for just a moment? Let me propose an alternative approach. So if number 1 is in the middle here and really belongs all the way there on the left, we went to great lengths, it seems, to shift all of these volunteers to the left, which is a lot of steps, because at the end of the day, let's assume for today's purposes that a computer can only do one thing at once. So even though all of you humans moved pretty quickly, that was really like one of you moved, then the next of you moved, then the next of you moved, then the next. So that was like 4 total steps just to put number 1 on the end there. Let me propose this. 1, can you pop out again? Now this list, so far as I'm concerned as the computer, is perfectly random from the get-go. So why do I even care that you guys move? I haven't even looked at the rest of these elements yet or done anything with them. Why don't I just evict number 4, where number 1 belongs, if you want to go over here? And if the list is already randomly sorted in the beginning, well, then fine, 4, you're going to go over here. So I've made the problem no worse, but I have made it slightly better by putting 1 on the end. Now I'm going to go ahead and select the next smallest element again. 2, I got lucky. Now I'm going to look for the next smallest element. 3, indeed, is the smallest. So let me do the same thing. 3, if you could pop back. 6, you're out of there. And notice that we're doing less work. Now, the humans are moving a little farther physically, but that's fine. The computer can just move values around in memory pretty fast, but I've moved fewer of you. So this is a slight optimization. It turns out this isn't fundamentally better, as we'll see, but it's this instinct that you should appreciate of trying to do the least amount of work possible, because otherwise it's going to add up. Let's try another one. Well, let me clarify one thing then. So what am I doing on each iteration of this algorithm? As you suggested, I'm selecting the smallest element. But the only catch is, if I'm now looking for the next smallest element, that's going to be 4. But I'm only sure that it's 4 once I get to the end and realize, yep, that was the smallest element, and then I act. So once we fix that problem, if you guys want to switch, I start again over here, and I have to find the next smallest element. And let's see, 8 is pretty big, 6 is smaller, good, 7 not smaller. But only once I get to the end do I realize, oh, here's the smallest. So in short, to find the smallest element, as you proposed again and again, I have to keep going through the whole list, because it might be all the way at the end. We humans have the advantage of just kind of looking, sort of taking a step back and saying, okay, this is obviously unsorted. I know where everything is. A computer can only look at one number at a time, one element of an array at a time. So let's try a fundamentally different approach. If you guys could reset to your original 8 locations, let me propose that we just looked at an algorithm we'll call selection sort. Selection sort insofar as you iteratively, again and again, select the next smallest element. Let's now do an approach that we'll call bubble sort, which has sort of the visual effect of numbers bubbling up over time as follows. You know what? I'm just going to look not at the whole list, because it felt like that was creating a lot of work for me. I'm going to look at two numbers at a time, 4 and 2. Are these in order or out of order? Obviously. So they're out of order. So you know what? I don't care about the rest of the problem. Let me just swap you two. All right, now let me take one step, look at 4 and 6. In order or out of order? In order, so I'm going to leave it be. 6 and 8, in order. 8 and 1, not in order, so let me swap that again. 8 and 3, out of order, let me swap that again. 8 and 7, out of order, let me swap that again. 8 and 5, out of order, let me swap that again. And now what has happened? Is the list sorted? Because I fixed all the pairwise mistakes. So obviously not, but is it better, the list? Why is it better, Derek? Yeah, exactly. 8 bubbled all the way up to the top, if you will. So now he is effectively done. And frankly, every other number that's smaller bubbled one step closer to its position. So we've taken one big pass through this to solve at least one of the problems. And now maximally 7 problems remain. So let me go back to the end here. And let me look at pairwise. 2 and 4, you're good. 4 and 6, you're good. 6 and 1, let's fix that. 6 and 3, let's fix that. 6 and 7, we're good. 7 and 5, let's fix that. And now I can ignore number 8 because I know the end of my list is sorted. So now I've improved it slightly. 7 has bubbled up to where he needs to be. I just have 6 problems left to solve at most. So now I look again. 2 and 4, you're good. Oh, 1 and 4, let's swap that. And notice 1 is moving closer to the left of the list. 4 and 3, let's swap. 4 and 6, you're good. 6 and 5, you're not. But now I fixed 6, and I can stop here, leaving me with just 5 potential problems. And then you can see where this is going. 2 and 1, let's swap. 2 and 3, you're good. 3 and 4, you're good. We already solved these problems, so let me go back. And now 1 and 2, you're good. 2 and 3, you're good. 3 and 4, 4 and 5, 5 and 6, 6 and 7, 7 and 8. What do I know now as the computer? What's that? It's sorted. Why? Everything is in order, but what does that mean? We humans can see that, but the computer can only look at individual values at a time. It can't take a step back and say, yep, sorted. Good. At a lower level implementation detail, I did no swaps. There were no 2 numbers that were out of order, so it would just be foolish of me and wasteful for me to bother doing another pass, because assuming the numbers are not changing on their own, I'm just going to do the same thing again and again otherwise, so I can just stop. And indeed, the bubble sort allows us to stop like this. Let's do one last approach, if you could. Let me toss the starting points on the board again. Let's reset one last time to this. And let me draw inspiration actually from the approach you took with the blue books, which was a little different from how we began, which was, recall that you took the problem on your left hand and you just dealt with it one at a time. You didn't go sifting through looking for A, you didn't go sifting through looking for B, you didn't go sifting through looking for C, which would really be the analog of what you proposed a moment ago. Instead, you just dealt with each problem as it came. And this is our third and final algorithm for sorting, called insertion sort. Take each problem one at a time and just deal with it then and there. Don't postpone. So here's 4. You know what? Done. I now claim that this list, which we'll visually make a little separate, is sorted. So I'm going to mentally divide my list into a left half and a right half. And now I just claim trivially, almost silly, this is sorted. Because it is. But now the right half of my list remains. So let's go ahead and do this. So number 2, okay, where does this belong? So if you want to go ahead and pick up the number, the sentence day, number 2 goes where? Here's my left list, and we'll make a little more space here just to be clear. It goes over this side, so what has to happen? So this time we do need to shift you over. So let's take 2 out. Let's shift 4 over, and now we won't move the stand. We'll just assume now that my left half is of size 2, and the right half is of size 6. But now the left half of the list is still sorted, but it cost me a little bit of work. I had to move 4 over. All right, let me deal with 6. Where does 6 go? Phew, it's already in order. I don't need to shift anyone. Where does 8 go? Phew, doesn't need to go anywhere. It's already in order. Uh-oh, 1, where does it go? Now we incur a good amount of cost, so let's do this. Where do you go? 1 shift, 2 shift, 3 shifts, 4 shifts. Feels, yep, as bad as our original approach, but notice I only have 4 more problems left. I don't have to keep going back through the list. So where does 3 go? All right, let's pop you out, shift you in there. Let's 7, we got a little lucky. Let's pop you out and insert you right where you belong. And then 5, you belong a few shifts over. So let's shift 3 of you. And then done. All right, so let's give all of you a stress ball and maybe a round of applause. And let's see if we can't tease apart what just happened here. All right. And then you can exit stage left if you, right if you'd like. All right, thank you. Derek, you're really racking them up here. All right. All right. Thank you. All right, so sure. So what was the point of this exercise, and how do we actually now get to a decision point where one of these is the way to go? So in bubble sort, recall that the key was to do something again and again until we did no swaps, at which point we could conclude that the list was sorted. So let's do exactly that. Repeat until no swaps, and then let's give ourselves a counter just to make things a little more methodical.
Okay,
and say,
so that's where I'm going to stop on that. So I just want you to see like the visual representation that he has in regards to how sorting works. And I forgot where we were. Oh, okay. So we were sorting. And see, he did it one way. And you saw how the book did it the other way. They created two functions, one ascending, one descending. One was A minus B, and the other one was B minus A. So there's multiple ways of doing the same way, multiple ways of doing the same thing. Let's see what W3 school says. So we're going to do array sort. Okay, so it says, we have a variable, we have an array, named fruits, banana, orange, apple, mango. We're going to sort it. So it'd be sort, I'm assuming alpha, apple, banana, mango, orange. I'll try it. Yeah, so we'll sort it after we click on the button. And the way this worked, we have a button on click. So this is an event listener is on click, and we're going to call function, and this function is down here. So we're going to do the array fruits, and we're going to sort it, and it's going to be yeah, we're just going to sort it, and we're going to input it, and then where we have the demo. So what's interesting is they just do the sort. They don't declare a function like the book did for ascending or descending. Well, they have this function, and in that function they're returning. They just did it differently. Let's see what else it says. So the sort method sorts the items of an array. I'm thinking ascending, descending for numerical reasons. Okay, my bad. So this is alpha, so that the numerical ascending and descending don't apply because I was thinking of numerical with a leading number like 1,234 versus 3. 3 is obviously the smaller number, but it was looking at the leading number of the 1. So that's why that worked as an example in the book. But this is alpha, so none of that applies. You can just do the array name of the array, fruits dot sort, and it's done. Okay, that's on this example, what W3 Schools has. It can be alphanumeric by ascending or descending. By default, the sort method sorts the values as strings in alphabetical and ascending order. This works well for strings. However, for numbers, it's 25 is bigger than 100 because 2 is bigger than the 1, the leading number. Okay. You can fix this by providing a compare function. And we go down to here. So this is what the book had. Optional function that defines an alternative sort order. This function should return a negative, 0, or positive value depending on the argument. So we have the function, and then we have the two parameters, A and B. And then we would, if we wanted to return ascending order, it would be A minus B, and descending would be B minus A. So it's when the sort method compares two values, it sends the values to the compare function and sorts the values according to the returned. For example, when comparing 40 and 100, the sort method compares the calls compare function of 40 and 100, 40, 100. This function calculates 40 minus 100 and returns a negative 60. And the sort function will sort 40 as a lower value than 100. Okay, so that's how it actually computes it, I guess, internally. Let's see. So sort numbers in an array in ascending order. So let's try this. So we have points in that order. So we have a function, and then we're going to sort the points with the function of AB. I'm going to put this on a different line just for aesthetics. And then document get element. We have the demo. Demo is going to pull up the points. That's running this function of A minus B. So what it does is that's a comparison of 40 and 100 in this one. So it'd be 40 and 100. And then so 40 minus 100 equals negative 60. And then so 40 would go before 100. So let's see if I can do math. No promises. Okay. Let's get rid of this. So we have our points of 40, 100, 40, 100, 1, 5, 25, 10. So we're going to do A and B sort. So it's 40 minus 100 equals 60, negative 60. So on the linear scale, we would, let's see. I don't have it open anymore. This is going to put that negative 60 right now. So now we're going to compare 100 minus, this is the new A, this is the new B. The number one is. So 100 minus 1 equals 99. This is the new A, number 1 is, and this is the new B, number 5 is. 1 minus 5 equals negative 4. The new A is number 5, and the new B is number 25. So 5 minus 25 equals 20, negative 20. And this is the new A, and this is the new B. 25 minus 10 equals 15. So if we're doing it in a linear fashion, the lowest number, which is negative 60, goes first. It's towards the left-hand side. So negative 60, and then we have negative 20, and then we have negative 4, and then we have 15, and then we have 99. So I think it's based off this number. No, it's not. So what I need is, maybe I'm not doing this right. Let's see what the instructions say again. So when the sort method compares two values, it sends the values to the compare function and sorts the values according to the return, negative, 0, and positive value. So when this function calculates that's negative 60, the sort function will sort 40 as the lower than 100. So it knows 40 is going to be less than 100. And negative 20 was, yeah, I don't think, yeah, that's not right. Let's see. I'm comparing 40 and 100 sort method. So Hmm. I think I did that wrong. Well, I know I did it wrong, obviously. So 40 minus 100 minus 1 minus 5 minus 25 minus 10. So 40 minus 100 equals negative 60. Negative 60 minus 1 equals negative 61. Negative 61 minus 5 equals negative 66. Negative 66 minus 25 equals 91. $101. Nope, that's not right either. Oh. So I get what it does. I understand what it does. I just want to understand how it does it. Let's see what this one says. So points 40 demo points by points sort function A B return B minus A. So that was in descending order. So 0 is the 0 index value is the 100 because it's descending. Okay, I get that. So a functional that defines an alternative order. So the function should return a negative, 0, or positive value, depending on the arguments. When the sort method compares two values, A and B, it sends the values to the compare function and sorts the values based according to, let's look up compare function. Okay, that didn't answer my question. Let's look up how does JavaScript array sort work? Let's try that. Let's see what developer.mozilla says. I know what it's supposed to do, I just want to understand it. The sort method sorts the elements of an array in place. So we have month sort, months, okay. Sort method sorts the elements of an array in place and returns the sorted array. The default sort is built upon converting the elements into strings, then it's comparing the sequences. So the syntax. So the compare function is optional. That's if we want to put some sort of definitive on the sort, like ascending or descending. Specifies a function that defines that sort order. So if it's not there, the array elements are converted to strings and then sorted based by default. So this would be in sequential alpha order, and this would be in order based off the leading number. We already know how that works with the sort. So it's going to do first element and second element, which has been A or B for us on this. And let's see. So it would sort it in place. So the compare function is not, if the compare function is not supplied, all non-undefined array elements are sorted by converting them to strings. So we got B before C, we got 9 before 80. 9 becomes before 80 because, oh, okay. But because it's reading the leading digits. Okay, we get that. I got that. If a compare function is supplied, all non-undefined array elements are sorted according to the return value of the compare function. If compare A and B, if compare function AB is less than 0, sort A to an index lower than B comes first. So A comes first. If compare function A to B returns 0, less than 0, return 0, leave A and B unchanged. If compare function A and B is greater than 0, sort B to the index lower than A. So B comes first. So compare must always return the same value with given a specific pair of elements. If consistent results are returned, then the sort order is undefined. So A and B, if A is less than B, return -1. If A is greater than B, then return 1. So that kind of comes up to here. If A is less than B, which would mean less than 0, A comes first. If A is greater than B, if A is greater than B, greater than 0, B comes first. And if it's returns 0, then it's the same, leave them alone. To compare numbers instead of strings, the compare function can simply subtract B from A. The following function will sort the array in ascending order if it doesn't contain an infinity and not a number. So we're doing a function of comparing numbers A and B, return A minus B. So if, based off what we were saying earlier, I want to get rid of that because that's not right. If function compare numbers A and B, I forgot what I was doing now. So if A is greater than B, let's do it this way. So if, just give me some rule skill. If A is greater than B, then just give me something with, that means A comes first. If A is equal to B, that means no change in order. If A is less than B, that means B comes first. No, a minute. So if A is greater than B, that means the value of A minus B equals is greater than 0. So i.e., let's do 100 minus 1 equals 99 and greater than 0. So A comes first. $100 shall come first. I thought I had it. So if, oh, I got it backwards. If B is greater than 0, but B comes first. So B comes first. So no change. That means the value of B minus A is less than 0. Less than 0. So i.e. 40 minus 100 equals negative 60 and is less than 0. So A comes first. I got that backwards there. Okay. I think I got that okay. So in the sort method, if we're using A and B, returning A minus B, let's try this one. This one right here. So we got 4, 2, 5, 1, 3. So in this regard, it's 4 minus 2 equals 2, which is greater than 0. So B, which is 2, comes first. So I'm going to just tab that over so I can have right there. So, and now I'm looking at, so it's 2 and then 4 so far, looking at those values. And then we do 2, no, I'm just going to put it up here. 2, this is how the order is so far. So now I'm looking at 4 minus 5 equals negative 1, which is less than 0. So A comes first, which is 4 comes first. So then our order will be 4, between 4 and 5, 4, then 5. So we got 2 and 4, We got that right there. So then we 4 still stays to the left because it's less and it's a negative. And then we go to 5. And now we're going to do a comparison of 5 minus 1 equals 4, which is greater than 0. So greater than 0 means B comes first. So B, which is 1, did I mess up again? Comes first. No, I don't think so. Okay, I'm good. So between 5 and 1, it's 1, then 5. So this 5 needs to go over here, and this is 1 now. And then, so we're looking at 5 minus 3. 5 minus 3 equals 2, which is greater than 0. So greater than 0, so B comes first. So B is 3, comes first. So then our order is 3, then 5. 3, 5. Okay, so we have a new sorted order. And just like that video that we watched with Harvard, it's better, but not quite there yet, right? It's not in sequential order. So let's do this again. I'm going to copy this down here. And A and B, and just do the whole process again. So 2 minus 4 equals negative 2, which is less than 0. So that means less than 0. A comes first. A comes first, which is 2. So we would have 2, then 4. So that stays the same. Now we're comparing 4 and 1. 1. 4 minus 1 equals 3, which is greater than 0. So that means B comes first, which is 1. So now we have 1 dash 4. 1, and moving the 4 over. So now we have 4 and 3 that we're comparing. 4 minus 3 equals 1, which is greater than 0. So that means B comes first, which is 3. So we now have 3, then 4, based off these two. B is first, so that's 3. So 3, 4. So now it's 4 minus 5 equals negative 1, which is less than 0. So that means A comes first, which is the number 4. So we would have 4 minus and 5, because A comes first, and then B. So 4 stays the same, and then 5 is right there. So the 1 is getting closer to the left, and the 5 is already to the right when it was originally in the middle. So it's making progress. See, this is why I do these videos. One of the reasons I do the videos is because of the fact that it helps me to be able to explain it to you without the pressure and the time constraints of being in a class. So, but you see me struggle because I told you before, math's not my thing. I want the answer like right here in this particular section. I just want to know what the answer is instead of, the problem solving aspect, which is fun once you start to get the hang of it, but Lord have mercy, it's frustrating when you don't. So then let's see. Same thing. This is fun now. I'm liking this now. So 2 minus 1 is 1, which is greater than 0, which means we will be using greater than 0 is b, which means b comes first. So that means it's 2 and 1 is now 1 and 2. One, 2. So now we're looking at 2 minus 3 is negative 1, which is less than 0, which means a comes first. So that would mean between 2 and 3, it's 2 and then 3. And then let's see. So we got 3 there. So now I'm doing a comparison between 3, and 4. So again, 1, 4, 4. So 3 minus 4 is negative 1, which is less than 0, which means a comes first. So 3, 4. Four minus 5 is negative 1, which is less than 0. Can't type. 0, which means a comes first. So it's 4, and 5. So we're almost there. So we can tell that this is in sequential order because we know as humans that this is sequential order. But the computer doesn't know it until it runs it through. That's what that video was talking about. Okay, so 1 minus 2 equals negative 1, which is less than 0. So a comes first, and that's 1 and 2. This might be an unnecessary last step, but let me just finish my thought process here. So 2 minus 3 equals negative 1, which is less than 0. So a comes first, which is 2, and then 3. 2, and then we have 3. 3 minus 4 equals negative 1, which is less than 0. So a comes first. And then it's 3 and 4. And then 4 minus 5 is 4 minus 5 equals negative 1, which is then 0. So a comes first. And okay, so nothing's changed. Like I said, this last step might have been unnecessary because the computer would have just seen it like they were talking about in that bubble sorting example. But I just wanted to finish out my thought process. I'm just tickled to death that I figured that out. Because I understood what it did, but sometimes you just get to the point and you understand why it does, and that's when it drives you a little crazy. But when you get the feeling of figuring it out, it's awesome. Okay, I'm just tickled to death that I found that. So I'm going to copy that link because that's what helped me figure it out. I'll put it there for right now. Okay. Is there any more on that one? Okay, so we did the sort. They did it with numbers, with the years, obviously. And let's go back to the tutorial. Maybe. Larry Daniel. Hey.
Well, as the youngest people. Now, this is really, really long. We could really cut that down by doing something like this. Ordered equals inventors sort, and you have A and you have B, and from that we are going to do what's called a ternary. I can't say it properly. Ternary operator. Whatever. Somebody once sent me a message after a talk and said you said ternary wrong, and now I'm self-conscious every single time that I say it. So from that, we want to have a ternary, which is like a shorthand if statement. The A.year is greater than B.year, and if that is true, return 1. Otherwise, return -1. And that is the exact same thing.
Okay, so let's do that. I'm just like feel like pumped since I figured out how that whole sort thing, how that worked. Camera. So we're doing the const ordered equals. So same thing as here. Inventors dot sort, exact same thing as this. But where we're doing is we're doing the A and the B. So we got the start of our sort there, the sort method. And we got our two parameters, which are going to be A and B. And we're going to do the function with the fat arrow. And we're going to say A dot year is greater than, get that box to go away, is greater than B dot year. And if it is, we do the question mark 1. And if it's not, it's like else, we do -1. So we are very similar, exact same thing. A here, we're doing the A and the B. We're comparing the first value and the second value. First value and second value. First value and second value. So just like on this, first value and second value. So theirs was year, so that's 4-digit values, but first value and second value. And then so got that. Oh, so let's talk about ternary values. So I'm keeping that. I'm just like tickled to death that I figured that crap out. Ternary values. File. Save as. Figuring out sort. Save it. Okay, ternary values. I don't know if I'm spelling it right. We'll find out. Nope, I spelled it wrong, but I knew what I wanted. Okay, conditional. Oh, stupid computer. Ternary operator. So JavaScript also contains a conditional operator that assigns a value to a variable based on some conditions. So we get a variable name, and this one's votable. It's if the condition, if it's less than 18, and we do if they are less than 18. So the first answer is if they are. So the first thing that you see, the first value that we see, like the first option, would be if this is true, what would we say? Okay, we would say they're too young. And then with the next question, it's like, if this is false, what would we say? So if it says this is true, it just stops. That's it. This is true, that's it. It's either or. But if it said this is false, then we want it to say this. So let's try this one. So JavaScript comparisons. So we got input ID, age, value 18. Button, click on button. There's try it. So we have a function, the function name. We have a variable. We got two variables, age and votable. Okay. So if age is a number, how are we doing this? Age equals is a number that is captured in here. Right now it's default to 18. So it's an ID. Remember the ID, usually they say demo on these, but that's what that is. Then we look at that value. Right now the default is 18. If is not a number, that's what NaN stands for, of age. If this age is not a number, then say it's not a number. Else, if votable is the votable variable, you had a variable named age and a variable named votable. If the age is less, if the age right here, this variable, calling up on that, is less than 18, we are going to say, hey, this person's too young, which is indicated with this question mark. If this is not true, Basically, if age less than 18, yes, then this person is too young. Is age less than 18? No, the person is old enough. So then we get the document, get element by ID demo, which is right here. And we would say that they're votable. So if this is not a number, if they don't put in a number, we're going to say, hey, you didn't put in a number. And or else, if it is a number, okay, they put some sort of number in there, then it's going to look at a variable named votable, and so it's going to take the age variable that we had up here, and it's going to do a comparison to the number 18, and then it's going to say whether or not it's votable. So let's try if we put 39, my age. Yep, I'm old enough. If I put 9, too young. So you can see based off what the parameters, what I put in here is, it determines what the output was. Let's say if I put key, and say input is not a number. So that's how you do a ternary operator, or conditional, whatever they call it, ternary. So you would just basically put a question mark right before the true answer. And so let's try this again. So if age is, let's put, is greater than, and hit run. So if I put the age is greater than 18, let's say I try 39 again, too young. So you can see how that makes a difference. I'm not sure what happens if you switch this question mark and the colon. Let's try it. Let's try this. Let's finish this thought out. So 9, it's old enough because it's saying age is greater than 18. Is my age greater than 18? I put 9 in here. No, it's not. So it's old enough. When I put 39, it's asking, is my age greater than 18? Yes, it is. So it says I'm too young. But let's fix that. Okay. So it should be back to what it should be, saying I'm old. And then there's nothing. Oh, let's see what this would do. I have no idea. I hit run. Okay. So what happens if I do 39? It just doesn't work. That's what it does. Okay, so that matters. Okay, back to being old. Let's see, what else did he talk about?
As what we were doing here, just doing it in one line with an arrow function, an implicit return, and a ternary operator. Let's double check that still works. Works great.
Okay, so I'm gonna double check mine. I'm gonna show you an error if I do this right. Oh, come on. Inspect. Try this again. Inspect. Inspect. There we go. There we go. So if I did this right, I should get an error message. Do the console log. Oh my goodness gracious. Console log ordered. Okay. So what that's telling me on 53, which is right here. See, the difference with you can using between using the words var and const and let. It's like on const, you can't use it. Whatever I named that, you can't use it again. That's just one of the things that make it const. That's just one of the qualities of it. But if I had named it var, oh, I got a different kind of error. 41. What the hell is that? I'll try that. Okay, so when I use the word var, I can use the same variable name. It's not always recommended because I can create problems, but that's the reason that they use things like let now. So if we use let, I think if I use let, I can use them both again like I do var. Oh, or not. I lied. So there are some limitations that there's some constraints that let and const do. Whereas when you just use the var, it can allow not as many constraints. So if I change this to ordered one, and then do the console log for ordered one, it should work. Yeah. I'm going to go ahead and change that back to ordered because that's how he has it. And I'm just going to comment this out. And the way you can comment it out quickly is selecting the area you want to comment out, hit the control and the /, which is the same key as where the question mark is. And then save it, Control S. And what's wrong now? Cannot access Word before. Oh, that needs to be commented out too. Okay. So this is a very long video because you saw me struggle, but I am going to keep that in there because I want you to see that you're going to struggle. I still struggle on some things. That's just not my thing. You may have seen the answer or had a good understanding, a grasp on it way before I did. I had to dive in a little bit deeper other than just accept that this is what happens. The curiosity of me just got, wanted to dive deeper as to why it happens. And sometimes you're going to find that that's awesome if you have the time and the resources to dive into the why instead of just what it does. That's great. But be careful not to get lost in the weeds of it. I was just, I don't know, I was in the mode to be curious and decided to dive into it. But just keep that in mind, okay? You're not going to, figure it all out one day for the things that you struggle with. And just take it one day at a time on those.